we'll return to this idea time and again as we go ahead in our study of physics. As we go ahead in our study of physics, the choice of the coordinate system, we'll go back to this point again and again, and perhaps also in mathematics, because it is related to one of the fundamental ideas, building blocks of mathematics and physics, which is symmetry. Now, I mentioned here that there is a third aspect, which is the constraint equation, which often will be a key part of the problem. And once again, we have already seen how the coordinate system is a big help in deriving the constraint equation in a formal way, but often leads to correct answers. So now let's get back to why I wanted to summarize vector resolution. So I'll refer to these points when I summarize. So typically in a solution of a problem, you will end up with a vector after you've drawn the free body diagram. Then with some practice, you will be able to figure out what is the good choice of the coordinate system. And initially you might think it's a little bit of a struggle, but pretty soon it'll be obvious to you that we should play around with a good choice of the coordinate system, and most often you will land up with the correct one. Now, given these two steps done, you will know the direction of your force, the force vector, and you will know the direction of your coordinate system, and you will know this angle. And you will want to convert this vector equation into two scalar equations, and that's what we wrote down last time, which is fx is equal to max and fy is equal to may. So for this, you will have to break up this vector as a sum of two vectors, and I strongly recommend that you draw the arrows. Why? Because first of all, it will be obvious to you that f is actually equal to f1 plus f2, where f is a vector, f1 is a vector along x-axis, and f2 is a